the invisible movers and shakers of the universe. Welcome to our exploration of the different types of forces. Isn't the universe amazing? Think about it. Everything around us is in motion or being acted upon. Forces are all around us, influencing everything we do. They keep us grounded, allow us to move, and even hold the very fabric of matter together. Over the next few minutes, we're going to dive into the amazing world of forces. We'll uncover the secrets of gravity, see how electromagnetism shapes our world, and even explore the forces at work inside atoms. Get ready for a wild ride. Have you ever wondered why what goes up must come down? That's gravity at work. It's the force that attracts any two objects with mass towards each other. The more massive an object, the stronger its gravitational pull. That's why we feel Earth's gravity so strongly. It's a giant. Gravity isn't just about keeping our feet on the ground. It's what keeps the Earth orbiting the sun. Can you imagine if the Earth just veered off into space? Gravity keeps our entire solar system together. And speaking of the sun, did you know it's constantly pulling on us? Yep, even from 93 million miles away, the sun's gravity affects us. It's a cosmic tug-of-war out there. But gravity isn't just about massive objects. It affects everything with mass, even tiny things like you and me. That's right, even you have a gravitational pull. It's just super weak because your mass is relatively small compared to, say, the Earth. Think about throwing a ball up in the air. As it goes up, it slows down because gravity is pulling it back down. And then, it falls back to Earth, accelerating faster and faster because of that same gravitational force. Pretty cool, huh? Now let's switch gears and talk about another fascinating force, electromagnetism. This force governs the interactions between charged particles, and it's responsible for some pretty amazing phenomena. Think about electricity. What is it really? It's the flow of charged particles, usually electrons. These tiny particles carry a negative charge, and their movement creates electrical currents. Without electromagnetism, we wouldn't have lights, computers, or even our smartphones. But electromagnetism is more than just electricity. It also encompasses magnetism. Remember playing with magnets as a kid? Magnets have two poles, a north pole and a south pole. Opposite poles attract while like poles repel. This magnetic interaction is actually a result of moving charges too. When electrons spin around an atom's nucleus, they create tiny magnetic fields. In most materials, these fields are randomly oriented and cancel each other out. But in magnets, these fields are aligned, creating a net magnetic field that can attract or repel other magnets. And there's more. Light itself is a form of electromagnetic radiation. It travels as waves of electric and magnetic fields, allowing us to see the world around us. Isn't it amazing how one force can be responsible for so much? Chapter 3. Now we're diving deep into the heart of matter, to the nucleus of an atom. This is where we find the strong nuclear force, the strongest of all the fundamental forces. And boy, is it strong. The nucleus of an atom is made up of protons and neutrons. Protons have a positive charge, while neutrons have no charge. Now, you might remember that like charges repel each other. So what keeps all those positively charged protons packed together in the tiny nucleus? That's the strong nuclear force. This incredible force overcomes the electromagnetic repulsion between protons, holding the nucleus together and making atoms stable. Without it, atoms would simply fly apart, and matter as we know it wouldn't exist. The strong nuclear force has a very short range though. It only acts over extremely small distances, like the width of a nucleus. But within that tiny range, it's incredibly powerful, about 10 to the 38th time stronger than gravity. To put that in perspective, imagine trying to pull apart two magnets that are stuck together. That takes some effort, right? Now imagine that the force holding those magnets together is trillions of times stronger. That's the strong nuclear force at work. Chapter 4. Don't let the name fool you. The weak nuclear force is still a force to be reckoned with. It's responsible for some pretty important processes, like radioactive decay. Radioactive decay happens when the nucleus of an unstable atom transforms into a more stable form. This transformation involves the release of energy and particles, and it's all thanks to the weak nuclear force. One example of radioactive decay is beta decay. In this process, a neutron inside the nucleus can transform into a proton, releasing an electron and a tiny particle called an antineutrino. This transformation is mediated by the weak nuclear force, changing the very identity of the atom. the weak nuclear force also plays a crucial role in nuclear fusion, the process that powers the sun and other stars. In fusion, lighter atomic nuclei combine to form heavier ones, releasing tremendous amounts of energy in the process. Without the weak nuclear force, stars wouldn't shine and the universe would be a much darker place. Chapter 5. Think about the last time you walked down the street. You probably didn't even think about it, but you were relying on friction to keep yourself from slipping and sliding all over the place. Friction is the force that opposes motion between two surfaces in contact. It's what allows us to walk, drive cars, and even hold objects in our hands. Without friction, our world would be a very slippery place indeed. There are different types of friction, including static friction and kinetic friction. Static friction is the force that prevents an object from moving when a force is applied to it. It's what keeps your furniture from sliding around on the floor when you lean on it. Kinetic friction, on the other hand, is the force that opposes the motion of an object that is already in motion. It's what slows down a book sliding across a table or a car rolling to a stop. The amount of friction between two surfaces depends on several factors, including the type of surfaces and how hard they are pressing together. Rough surfaces tend to have more friction than smooth surfaces. That's why it's easier to walk on a sidewalk than on a sheet of ice. Friction isn't always our friend though. It can also be a nuisance, like when it causes wear and tear on moving parts in machines. But overall, friction is an essential force that makes our world a much more livable place. And there you have it, the different types of forces that shape our world. From the vast gravitational pull of planets to the tiny but mighty strong nuclear force, these forces are constantly at work, influencing everything around us. Forces are pretty amazing, wouldn't you say? They're behind so much of what we see and experience every day. So next time you see an apple fall from a tree, think about the force of gravity pulling it down. Or when you turn on a light, remember the power of electromagnetism. And when you look up at the stars, marvel at the incredible forces at work in those distant suns. Thanks for watching and stay curious. There's a whole universe of science out there waiting to be explored.